Hi, good afternoon, everyone, and thank you for joining us for our webinar today, Understanding Martin Professional's Creation of GDTF Files. My name is Claire Manley, and I'm the Marketing Specialist for GDTF and MVR. And before we jump into the presentation today, I just have a couple quick housekeeping items I want to run through. First, this webinar is being recorded, and it will be posted to the GDTF YouTube page, where you'll be able to find this, as well as all past webinars and some additional training content. Also, if you have questions at any time, please feel free to write them in the questions box, which is located right in your control panel, and we'll save some time at the end of the webinar to get through as many of those questions as possible. So without further ado, I'd like to introduce our guest presenter for today, Wouter Verlinden. Wouter has had a passion for electronics and lighting since the age of 16, even building his own lighting console back in those days. In 2009, he joined the team at Martin Professional as product manager. And today he oversees the development of various lighting, creative LED, and control products. So let's give a warm welcome to Wouter and let's go ahead and get started.
Thank you, Claire. So yes, I'm Wouter Verlinden, one of the product managers here at Martin Professional. Let's have a look at how we create GDTF files. But first of all, who is Martin Professional? We started in 1987 by turning a coffee machine into a smoke machine on purpose, actually. Right now, our main development center is still in Aarhus, Denmark, as it was back in '87. And we now also have a second development center in Shenzhen in China. Our main manufacturing plant is located in Pécs, Hungary, in Europe. And as most of you probably know, we make a wide variety of products going from moving heads, static lights, creative LED fixtures, but we also do architectural lighting, atmospheric effects such as smoke and haze machines, and also the Martin P3 video processor. So a very wide portfolio of products. So what is GDTF? I always look at it as a universal personality file format. So a way to describe fixtures for lighting consoles, media servers, visualizers, and CAD software, but now in a universal format so that it works across multiple different platforms and is not specific for one console or visualizer. Besides being used in lighting consoles and entertainment applications, GDTF files are also more and more used in 3D gaming engines, in smartphone apps, so we see them being used widely, so it's definitely works for us at Martin to look into this. In general, if you have any questions about GDTF files for Martin fixtures, we've set up an email address for this, so it is gdtf@harman.com, so there you're more than welcome with any questions you may have regarding GDTF files for Martin Professional products. So first of all, why do we support GDTF? Well, the baseline is our fixtures are only as good as they can be controlled or visualized. We've all been there. A faulty personality file is extremely annoying. We've seen this many times with Martin fixtures. A Mac Aura fixture where the Aura backlight wasn't included in the personality file, or fan modes are missing from the control channel. All of this is very frustrating when you're programming your show. But at the same time, we at Martin, we do not have the bandwidth to build, test, and support 20 different personality files for all the different consoles, visualizers, and CAD programs out there. We try to support them as much as we can by sending information on new fixtures as we launch them, but we cannot ourselves make 20 different files for all of these systems. Now, GDTF, it allows us to build and test a single file which supports multiple systems. So we can put the effort into making one file and thereby support many different consoles and visualizers and more, and hopefully even more in the future. The Martin GDTF files actually supplement what we've already been doing for almost 10 years, and that's make AutoCAD symbols and Vectorworks symbols. So for us, it's a very good reason to support GDTF and get good personality files out there supporting many systems. So how do we create GDTF files? It's very much a collaborative effort. The GDTF files contain a lot of different data from R&D, so we have optical engineers bringing in the photometric data, the color data. We have our mechanical engineers bringing in the fixture model, effect speeds, and all of those types of parameters. Our firmware engineers They bring in the DMX layout and how every channel behaves to the greatest detail. And then our Gobo artist, he brings in Gobo and animation wheel artwork. So all of that data is collected from the R&D team, and we all bring it together in one single GDTF file. Then we test the GDTF file, and then we publish the GDTF file. So what do we put inside a GDTF file? What's the key information in there? Well, you have some basic fixture information, you have a 3D fixture model, you have all the photometric data, you have the DMX channel layout, you have a ton of artwork, and then you have physical behavior description, which I will get into later. And important to know is a lot of this data is typically not very easy to get to, like photometric details and good quality artwork or physical speeds of fixtures. If you're building your own personality file, it's not easy to get to, but because we manufacture the fixture, we actually have all that data or can measure all that data. So for us, it's quite easy. It's still some work, but it's easy to get all that data and make a high quality file. So first of all, the basic fixture information. So what is this? It's the name of the fixture, the weight, the minimum maximum ambient temperature, the RDM device model ID. So few products could use this to automatically discover which personality file belongs to which fixture, a fixture thumbnail, which is typically a picture, and then a fixture symbol. So that's kind of the basic information at the top of a GDTF file. Secondly, there's also a 3D fixture model. So it's based around the 3ds file of each fixture element, so the base, the yoke, the head. And we actually build these specifically for GDTF. So this is not just our R&D drawings, it's actually specifically optimized for GDTF in terms of vertex count, so that these files are running smoothly in the visualizer. If you would just take the R&D drawings, 3D models, it would be way too heavy for visualize. So for GDTF, we purposely built 3ds files for smooth visualization. The 3D fixture model also contains accurate positioning of each LED. So like the Mac Aura PXL, you see here there's a ton of LEDs, beam and Aura, and all of these are correctly mapped in the 3D model. So in the visualizer, you see exactly how the fixture will behave and look. Second pack of data is the photometric data. So first of all, basic stuff such as beam angle, field angle, the beam diameter, the luminous flux, but also the CIE 9031 XY coordinates of each emitter in a RGB white fixture, for example, the coordinates of each color flag and each filter on a color wheel, and also the coordinates of every virtual color on a fixture such as a Mac Aura PXL. So very accurate data, really helping a visualizer to show exactly the color that will come out of a fixture. And also on a console, when you pick a color in the color picker, it will be exactly that color because we've put the exact configuration of the fixture and then the color space into the GDTF file, so the console knows exactly what it needs to do to hit a certain color. Also, the prism definition in there is in there, so we describe exactly how one or multiple prisms behave and how the light will come out of the fixture. Of course, a GDTF file also contains the DMX channel layout, so every DMX channel in every DMX mode, and also includes an accurate definition of each function within the DMX channel. So for example, like on a color channel where you have the different fan modes, reset behavior, pan tilt speeds, dimmer curves, all of that is described in GDTF. So every functionality that the fixture has is described in detail and will appear on the console as it's meant to be from a product perspective. All of that is linked to the 3D fixture model. So if you control a fixture, the visualizer also knows what DMX channel affects which part of the model. And as I mentioned, nothing remains undescribed. So every little detail on the DMX layout is described inside the GDTF file. Then artwork. So all the different gobos and animation wheels, all of that artwork is being put in the GDTF file. And given the fact that it's our own gobos, we we can put the actual source files, the high resolution images in there, not just taking a screen grab from the user manual or something. We actually have the high quality source files, so that greatly improves how they look on the console or on a visualizer. And then last but definitely not least is what I call the physical behavior description. That's how a fixture behaves in great detail in terms of speeds and acceleration and such. So strobe rates of a shutter, they're programmed in the GDTF file, the actual color temperature range, the rotation speeds of color wheels and gobo wheels, the ratio of an iris and the speed of an iris, the rotation speed of a prism, the actual zoom angles and the speed of the zoom, the complete description of how the framing blades enter, their min-max angles, their speeds, and of course also the pan and tilt angles and speeds. All of this helps. Two things. First of all, on a visualizer, the fixture will behave much more as it behaves in the real world, because now the visualizer via the GDTF file knows exactly how the fixture behaves. But also on a console, I can now pick angles just by angle instead of just a random DMX value, because the console also knows how this fixture behaves in the real world. So all in all, a big step forward in terms of detailed fixture description. So how do we test GDTF files? For new fixtures that we are still developing, we build the GDTF file while we are developing the fixture. So that means that the GDTF file is tested alongside the fixture. They go through the process together. So we're gradually moving more and more of our own teams to use MA3 because that uses GDTF files as well, away from some older software that we used to use. But this means that a lot of people inside are now actively using GDTF files, which means that the files get a lot more testing before we publish them together when launching the fixture. When do we publish GDTF files? For new fixtures, our aim is always to publish a GDTF file on the day that the fixture is launched. So if we announce something like the Mac Ultra, as we did earlier this year, the same day the GDTF file was available on the share. So you can immediately download the file and test the fixture on your console and visualizer and get a feel of it before seeing it for real. Of course, there's a large backlog of fixtures that Martin has done over the last 30 years. So for all of these existing fixtures, we're obviously in a catch-up mode. We need to work backwards and make GDTF files for all these fixtures. Currently, we're at 33 GDTF files, so that's not bad, but far from where we want to be. So there's still a lot of work ahead of us. As I mentioned, our goal is to cover the entire portfolio, our entire product portfolio, so everything we have right now, including all the legacy products that still make sense to do. But of course, all of this takes time, as we generally steer away from publishing quick and dirty files. So for all the files, we want to do all the measurements, get photometric data in there, make an accurate 3D model. So we take our time to make a good file rather than just trying to make as many files as we can. So there's one special exception on our GDTF files, and that's the so-called no measurement GDTF files. These files, they are fully working and tested, but they do not contain all the measurements. So it's typically for new fixtures where not all measurements have been done. So it means that in such file you might not have the physical speed. So in pan tilt, in a visualizer, it will be move not as accurate as the fixture itself, or accurate fixture photometric data might be missing. All the other data, like a 3D model, a DMX layout, the gobos, it's all present in such no measurement files, so they will work perfectly fine. It's just there's some fine-tuning in the visualizer in terms of speeds and photometric data, which isn't there. So we usually do this to make a file available, even if some of the measurements still need to be completed. But as I mentioned, these files work perfectly fine. They're just some details that will be added later, and then the no measurement flag will be removed from the file. So how do you get Martin-made GDTF files? There's actually multiple ways. The easiest way to get to our libraries directly from the martin.com product page, so any product for which we have a GDTF file, will have a link to the GDTF library there. So here you see it on the Mac Ultra product page. In downloads, you will see a link to the GDTF library. Clicking that one brings you directly to the Martin Professional page on the share, which does not require login. So to download any of those files, you don't need to log in or anything. You just get to the Martin Professional page, and there you see all the Martin GDTF files, and you can just download them as you need them. You can also just browse to the GDTF share itself. There you do need to log in, then you can browse the entire library. And there it's quite important, if you want to get the Martin-made files, that you click the manufacturers only flag. So once you click that, you're sure that you will only see GDTF files that were made by us, made and tested by us. When you open them here, you can also open them in the online GDTF builder, and there you can look into the details of the fixture, find pen tilt speeds, find actual colors, find the DMX layout. All of that information is in the GDTF file, which you can then browse and open in the online GDTF builder. A last way to get a GDTF file, and maybe this is implemented in other consoles as well. I have not looked into it yet, but I know in the latest MA3 software, when you patch a fixture, you can just click GDTF share, which automatically downloads files online if your console is connected to the internet. So there, you do not need to download a file and then import it. You can go directly online and download it directly to your patch. So what if your software does not support GDTF yet or at all? So even if your console, your visualizer does not support GDTF, you can still use the files to get a lot of, as I call it, high quality information to make a proprietary personality file for that console or visualizer. So a GDTF file is actually just a archive file, so you can open it with a program such as 7-zip. And then if you open it, you will find images of the gobos, you will find the 3D model of the fixture, the 3ds files, you can extract the color points, you can extract the fixture symbol, SVG file. So even if you're making your own personality file for another system that does not support GDTF, you can extract a lot of this information from a GDTF file just by opening it with a program such as 7-zip. But of course, in the long run, we hope that more and more consoles, visualize and CAD programs will get on board with GDTF, so we get even more usage out of our work by just being able to use the files that we provide. So what are our future plans with GDTF at Martin? Well, of course, we will continue to publish GDTF files for new fixtures as they become available. That's a given. And we'll also continue to work backwards to create GDTF files for legacy fixtures. Of course, that's a longer effort to go back in history and make as many GDTF files for older fixtures as we can. Martin is also actively involved in the monthly GDTF meetings, so we get involved in the latest developments. We want to know if there's going to be new versions or new features added to the standard. So of course, as there's new versions of the GDTF standard published, we know about this, and we update our Martin-made GDTF files to be compatible with the newer versions of the standard as well. And then something we haven't spoken about, which kind of a sister standard to GDTF, is the MVR, My Virtual Rig standard. So it's basically a format to exchange a fixture patch and fixture coordinates between different software. So you can create a patch and a layout in, for example, Vectorworks, and then export this and import this straight into your console and automatically get a patch and the mapping across the other software. Our slightly longer term plan is that we also want to add MVR support to the Martin P3 system controller. So our video mapper for our creativity and moving at fixtures, so that you can also import a patch from any console into the P3, or the other way around, create a patch and a mapping in the P3 and export that to your console or visualize. So this is something on our roadmap as well, which will, of course, very much simplify workflows with the P3 controller as well. Avoiding you to have to do the work twice. You no longer need to do mapping twice or patching or creating a patch twice. You can automatically transfer this information with NVR. So that's on our roadmap as well. So that was basically it. I hope this gave you a good introduction of GDTF at Martin. If you have any questions, you can type them in the box right now, and I'll be more than happy to answer them.